So now we're in a position where we can describe what the binomial distribution is. So we've got a random variable x, which is the number of successes. In n, and we normally call them trials or experiments. So n trials. And each trial, like we had before, is either a success or a failure. And the probability of success on a given trial is p. And we know that the probability of x being equal to x, so the probability of getting x, little x, number of successes, we worked that out in a previous video. That's n, choose x, and then we're going to have p to the power of x and 1 minus p to the power of n minus x. And you actually get given this in your formula book. And you can watch the previous video to see where this formula comes from. Well, we don't want to have to keep on writing out this information each time. So this information, what we do is we say that this random variable has a particular name. We say that x is a binomial random variable. And binomial random variable basically means that x is going to count the number of successes in a certain number of trials. Well, the problem is I can't just say x is a binomial random variable because I need to say how many trials there are and what's the probability of success. So a shorthand way of writing that is to say x follows a binomial distribution with n trials and p is the probability of success. And a shorthand way of writing that, you don't need to write binomial in full each time, you can just write b or bi. So this is the notation. So this is our random variable, which is going to be the number of successes we have. This squiggle you read as follows. B stands for binomial. N is the number of trials that you're doing. And P is the probability of success on each trial. So let's look at example 4 then. So here we've got x, which is a random variable which follows a binomial distribution with 12 trials, n is 12, and p, the probability of success, is a sixth. So let's write that down. N is the number of trials, which is 12, and p is the probability of a given trial being successful, so probability of success, which is a sixth. So for example, I might be flipping a coin 12 times and the coin is biased towards tails, so the probability of getting heads is only a sixth, and I'm counting up how many heads we get. So here we want to work out what's the probability of having 2 successful trials. So we're just going to use the formula. The formula is 12 n choose x, let's write out the formula actually, n choose x, p to the power of x, 1 minus p to the power of n minus x. So we're going to have 2 successes. So on our probability tree, we're going to have a sixth to the power of 2, because we're going to go down 2 success branches and times n together. And then we're going to have a certain number of failures. Now the probability of failure is 1 minus a sixth, so 1 minus p. And the number of failures that we're going to have is 12 take away 2. Because if we do 12 trials, 2 of them are successes, then 10 of them are going to be failures. And then this choose at the start tells us how many different ways are there of placing the 2 successes amongst the 12 trials. So we're going to put 12, choose 2. And we're timesing all of these together. So that's 12, choose 2 times the 6th squared times by 5/6 to the power of 10. And we can just type that all into our calculator and we can get that as 0.296. Rather than using the formula each time to find the probabilities, your calculator actually has a built-in binomial function. So if you go to Statistics and then dist for distribution and then binomial, and you want PD to give you a specific value of x, you'll need to change list to var if it's not already at the top. Now x is the value of x that you want the probability of. So here we want the probability of x equaling 2. Number of trials is 12 and the probability of success P is a 1/6. And that will give you what's the probability of having 2 successes for x being 2. Okay, so in B, we want to work out the probability of x being 9, so probability of x equaling 9. So the number of ways of getting 9 successes is 12 choose 9, and then we need to times that by the probability of success, which is a 1/6 to the power of 9, times by the probability of failure, and then if we have 9 successes, then we're going to have 3 failures. And notice that that both of the powers add up to 12, just like when you do the binomial expansion. And similarly, 12 choose 9, the 9 matches the power of the number of successes. And that probability is a very, very small probability. So 1.26 times 10 to the power of -5. So very unlikely that's going to happen. And that's because the probability of success is only a 1/6. Again, we could use our calculators to find this probability. Distribution, binomial, PD for a specific value of x, and just change x to 9, and that will give us the probability of having 9 successes, the probability of x being 9. And then in part C, we want to work out what's the probability of x being less than or equal to 1. So we've got to think, what could x be equal to for this to be true? Well, if we want the probability of having 1 or less successes, we could have 0 successes, so the probability of x being 0, or we could have 1 success, so the probability of x equaling 1, and we'd have to add them together to work out this one happening or this one happening. So let's use our formula. This is going to be 12 choose 0 times a 1/6 to the power of 0 times 5/6 to the power of 12 plus 12 choose 1, a 1/6 to the power of 1 times 5/6 to the power of 11. And this is obviously just 5/6 to the power of 12, because this is the same as saying if I have 0 successes, then I'm going to have 12 failures. So we can work out what this is, and that's 0.381, that probability there.